Today we start the second part of atomic structure. So we start with nucleus and extranuclear region. On the last video we found that according to Rutherford's nuclear model of atom and Bohr's nuclear model of atom, the total mass of an atom is centrally located. In which region? In the nucleus. The nucleus contains two particles, protons and neutrons, okay? And it is surrounded by rings which are actually shells or orbits, specifically known as energy levels in terms of chemistry, and these orbits contain electrons revolving around them continuously. Alright, so let us find out how the structure was. So this was the centrally located nucleus which contains the neutrons and protons. Okay, I am writing the short forms. This is neutron and P represent protons, okay? And surrounding the nucleus there are shells. There are shells which are known as orbits or energy levels. The shell nearest to the nucleus was named as the K shell, and as we went further away from the nucleus it became K, L, M, N and so on, okay? So K, L, M ... these are the energy levels. Is it clear? And on these energy levels there are electrons which are continuously revolving around the nucleus, okay? So these dots are representing electrons. You can also represent it as E minus, okay? But you can easily represent it by dots. It is much easier and it is much convenient. স্কুলে যেটা বলবে সেটা দিয়ে একবার রিপ্রেজেন্ট করতে পারো, কোনো অসুবিধা নেই, ওকে? E stands for electrons. So the nucleus and the extranuclear region, okay? So what is found in the nucleus and what is found in the extranuclear region? So the nucleus consists of protons and neutrons, okay? So the nucleus consists of protons and neutrons. Protons are positively charged whereas neutrons are negatively charged, okay? Protons are positively charged whereas neutrons are negatively charged, okay? Completely incorrect. Yesterday only I corrected you that neutrons are neutral. These are neutral, okay? They do not carry any charge. Always remember this. Neutrons are neutral, protons are positive, electrons are negatively charged, okay? In the nucleus there are two particles, protons and neutrons, out of which proton is only the charged particle. Neutrons are neutral. Clear? Therefore proton and neutron together form নিউক্লিয়ন. দিস টুগেদার ফর্ম নিউক্লিয়ন. এটা নেম দ্য ফলোইং এ খুব আসে, ঠিক আছে? যে প্রোটনস আর নিউট্রনসকে একসাথে কি বলা হয়? দে আর কল্ড টুগেদার নিউক্লিয়নস. ক্লিয়ার? নাও নিউক্লিয়াস forms the entire mass of an atom. Why? Because mass of electrons is negligible, so total mass of the nucleus is concentrated due to presence of protons and neutrons, okay? Neutrons are the heaviest particle, protons are lighter than neutrons, and electrons are almost having negligible mass, okay? And moreover nucleus is positively charged, okay? Because of the presence of neutrons or protons, because of the presence of protons. Clear? Always remember neutrons are neutral. Always remember that neutrons are neutral. Clear? এই ভুলটা সবাই করে, বারবার বলছি নিউট্রন নিউট্রাল, নামটার সাথেই মনে রাখবে, নিউট্রন নিউট্রাল. তাহলে নিউক্লিয়াস পজিটিভলি চার্জড কেন? কারণ presence of protons. Protons are positively charged, hence the nucleus is also positively charged. Clear? And lastly, neutrons carry no charge. Always remember this. Neutrons carry no charge. Clear? Okay, so the extranuclear region consists of energy levels or the shells, okay? They consist of energy levels or the shells, and they consist of negatively charged electrons. They consist of negatively charged electrons. Clear? And charge of electrons is -1. Electron charge can be written as -1. Or if you want to write it in coulombs, you can write it as 1.6 minus 1.6, they are negatively charged, into 10 to the power minus 19 coulomb. Okay, coulomb is the SI unit of charge. Remember, coulomb is the SI unit of electric charge. Okay, if you consider charge of proton, the charge of proton will be plus 1.6 into 10 to the power minus 19. Okay, charge on protons, it can be written as plus 1, which is equal to plus 1.6 into 10 to the power minus 19 coulomb. Is it clear? As electrons have negligible mass, so extranuclear region does not add to the mass of an atom. Okay, extranuclear region does not add to the mass of an atom because electrons have negligible mass. Electrons have negligible mass, and so electrons do not add up to the mass of an atom. So we can conclude that extranuclear region does not add up to the mass of an atom. Only the nucleus adds up to the mass of an atom. Nucleus is positively charged and extranuclear region is negatively charged. Nucleus is positively charged due to presence of positively charged protons, and the extranuclear region is negatively charged due to presence of negatively charged electrons. Clear? So from the above data we can conclude that an atom always has equal number of electrons and equal number of protons. মানে কি, ইলেকট্রনের সংখ্যা equals to প্রোটনের সংখ্যা, ঠিক আছে? So we can say that overall charge is 0. Okay, I am explaining this. Overall charge is 0 and whether an atom is neutral with an example. Let us check out an example. So let us take the example of sodium atom. Sodium has 11 number of protons. Okay, it has 11 number of electrons and it has 12 number of neutrons. So let us represent the atomic structure using the orbit diagram. এই ধরনের ডায়াগ্রাম যেটা নিউক্লিয়াস আর শেল দেখানো হয় এটাকে বলা হয় শেল ডায়াগ্রাম অথবা অরবিট ডায়াগ্রাম, ঠিক আছে? তাহলে p equals to 11, n equals to 12. In the first shell, that is the K shell, there are 2 electrons. In the first shell, which is K shell, there are 2 electrons. So out of 11 electrons, 2 electrons are in the first shell. So how many electrons are remaining? There are 9 electrons remaining. In the second shell, there are 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I will explain why there are 8 electrons and why there are 2 electrons in the next part. I am just explaining the example to show why an atom is actually electrically neutral. Okay, and another electron is remaining. So the other electron will remain in the last cell, which is the M shell. Okay, so 1 electron is there in the M shell. So the electronic configuration of sodium is 2, 8, 3. That means there are 2 electrons in the K shell, 8 electrons in the L shell, and 3 electrons in the M shell. Clear? There are 2 electrons in the K shell, 8 electrons in the L shell, and 3 electrons in the M shell. Is it clear? Okay, so let us calculate the overall charge of the atom. Okay, number of protons equal to 11. Therefore, charge of all protons, each proton has charge plus 1. Therefore, charge of all protons equal to plus 11. Okay, now the number of electrons equal to 10. So charge on all electrons, how much? Minus 1 into 10, because charge on 1 electron is minus 1. So minus 1 into 11 minus 11. Okay, therefore overall charge is plus 11 minus 11, which is equal to 0. So we find the overall charge of the atom is 0. Therefore sodium atom is electrically neutral. Clear? You can find this with any other atom. Okay, you can find this with any other atom. Oxygen, you can take nitrogen, carbon, magnesium, fluorine, aluminium, silicon, phosphorus, potassium. You can take any atom, you can use this method, and you will always find that overall charge is 0. Why? Because in an atom, number of protons is always equal to the number of electrons. Is it clear? So an atom is always electrically neutral. Okay, so for representing an atom, okay, to represent an atom, we need to know its mass number and atomic number. So let us know what is atomic number, what is mass number, and how it is used to represent an atom. So let us start with atomic number. Okay, atomic number is represented by capital Z. Okay, atomic number is represented by capital Z. All right, it is the number of protons present in the nucleus of an atom. Okay, so it is the number of protons present in the nucleus of an atom. This is very important. Okay, atomic number is always represented by capital Z, and it is the number of protons which are present in the nucleus of an atom. So what is the atomic number of sodium? Sodium has 11 protons in its nucleus, so the atomic number of sodium is 11. So we can write atomic number of sodium is 11. Okay, this is very important. Okay, so we can say, since atom is neutral, so number of proton is equal to number of electron. That means for an atom, mind it, for an atom we can consider atomic number as both number of protons as well as number of electrons. But as soon as an atom loses electron or gains electron, atom does not remain neutral anymore. It becomes ion. বোঝা গেল কথাটা কি বললাম? এটাই বলতে চাইছি যে ইলেকট্রন কিন্তু ট্রান্সফার হবে, একটু পরেই শিখবো যে ইলেকট্রন ট্রান্সফার হবে স্টেবিলিটি পাওয়ার জন্য, স্টেবল ইলেকট্রনিক কনফিগারেশন আনার জন্য ইলেকট্রন একে অপরের মধ্যে ট্রান্সফার করবে। এবার যেই না ইলেকট্রন ট্রান্সফার হবে, সঙ্গে সঙ্গে আমি কি বলে দেবো? সঙ্গে সঙ্গে আমি একদম ক্লিয়ারলি বলে দেবো যে না, তখন আর ওটা অ্যাটম থাকছে না, তখন কি হয়ে যাচ্ছে? ওটা আয়ন। তাহলে অ্যাটমের ক্ষেত্রে ওই জন্য সবসময় বলা হয় অ্যাটমিক নাম্বার কি? নাম্বার অফ প্রোটন, নাম্বার অফ ইলেকট্রন দিয়ে বলি না, কারণ কি ইলেকট্রনটা তো অ্যাটম থেকে ট্রান্সফার হয়ে যায়, কিন্তু প্রোটন ওইভাবে সহজে ট্রান্সফার হয় না। বোঝা গেল? তো অ্যাটম যেহেতু নিউট্রাল, তাই জন্য আমরা কিছু কিছু ক্ষেত্রে বলতে পারি যে হ্যাঁ দেখো, ইলেকট্রনের সংখ্যা আর প্রোটনের সংখ্যা সেম, তাহলে অ্যাটমিক নাম্বার ক্যান বি number of electrons or the number of protons, but it is better to say that atomic number is the number of protons rather than we tell that atomic number is the number of electrons, because electrons can be transferred from one atom to another. As soon as electrons are transferred, the atom no longer remains an atom because the charge is not zero anymore. It becomes ion. It either becomes positively charged ion or it becomes a negatively charged ion. Clear? Therefore we can write Z equals to number of P, that means number of protons in an atom. Clear? Z equals to number of protons in an atom. Clear? Okay, so moving to the next topic. The next topic is mass number. What is mass number? Mass number is the total number of protons and neutrons. If we calculate the sum of the nucleons, okay, the sum of all the নিউক্লিয়ন্স, or the total number of nucleons. নিউক্লিয়ন্স মানে কি বলেছিলাম? প্রোটন আর নিউট্রন মিলিয়ে যেটা নিউক্লিয়াসে থাকে সেটাই নিউক্লিয়ন, তাই তো? তাহলে টোটাল নাম্বার অফ প্রোটনস অ্যান্ড নিউট্রনস ইন অ্যান অ্যাটম ফর্মস দ্য মাস নাম্বার। ওকে, মাস যারা বানাচ্ছে তাদের সংখ্যাটাই হচ্ছে মাস নাম্বার। তো অ্যাটমের মাস কে বানায়? হু ইজ রেসপন্সিবল ফর মাস অফ অ্যান অ্যাটম? প্রোটনস অ্যান্ড নিউট্রনস। সো হোয়াট ইজ মাস নাম্বার? দ্য নাম্বার অফ প্রোটনস অ্যান্ড নিউট্রনস ইন অ্যান অ্যাটম। এত রকমভাবে তুমি মাস নাম্বারকে মনে রাখতে পারো, ঠিক আছে? মাস নাম্বার ইজ রিপ্রেজেন্টেড বাই দ্য অ্যালফাবেট ক্যাপিটাল A. Okay, so A equals to number of proton plus number of neutron, therefore A equals to P plus N. Clear? Okay, so how can we represent an atom using atomic number and mass number? Okay, so if we consider an atom X, let an atom be X. এক্স নামক একটা অ্যাটমকে আমরা ধরে নিচ্ছি। তাহলে এক্সকে আমরা কিভাবে লিখব? জেনারেলি লেখা হয় এইভাবে, এক্স এর মাথায় এ, নিচের দিকে জেড। ঠিক আছে, এক্স এর মাথার উপরে এ, নিচের দিকে জেড। তার মানে এক্স এর উপরের দিকে যেটা লেখা হবে সেটা হচ্ছে কি মাস নাম্বার, আর নিচের দিকে লেখা হবে যেটা, সেটা হচ্ছে ওর অ্যাটমিক নাম্বার অফ দ্যাট পার্টিকুলার অ্যাটম। ওকে, therefore how can we write sodium? Sodium has n equals to 12, p equals to 11, e equals to 11. Therefore mass number of sodium equals to n plus p equals to 12 plus 11, 23, and atomic number equals to number of protons, which is equals to 11. Therefore sodium is written as Na. Sodium symbol is Na and it is written as 2311. Okay, Na 2311. You can write in some other ways also. You can write it like this way, Az, that means Na 2311, or you can write it as Za, that means Na 1123. But mind it, when you write it, follow only one method. Do not mix all the methods in your answer sheet. অ্যান্সার শিটে যখন লিখবে তখন যে কোনো একটাই লেখো, সবচেয়ে বেটার যে এটা লেখো। ঠিক আছে, এটা সবচেয়ে বেস্ট ওয়ে অফ রিপ্রেজেন্টেশন, সবচেয়ে ভালো এটাই লেখো, এটা সবচেয়ে বেশি ইউজ হয়। ঠিক আছে, আর যদি মনে করো যে না আমি এইভাবে লিখবো বা আমি এইভাবে লিখবো, তাহলে পুরো কপিতেই কিন্তু এইভাবে লিখবে। ঠিক আছে, এগুলোতেও কোনো ভুল নেই, দিস আর অলসো কারেক্ট, বাট প্রেফারেবলি ইউ রাইট ইন দিস ওয়ে। ওকে, okay, so from the above representation we can find some specific formulas, like ধরো কিছু বলে দিল, কিছু আননোন দিয়ে দিল, তো সেটা কিভাবে বের করব, সেটাই ফর্মুলা দিয়ে আমরা ইউজ করতে পারি। সো হোয়াট আর দ্য ফর্মুলাস? তো ফার্স্ট অফ অল we found A equals to n plus p. Therefore number of neutrons equals to atomic mass minus number of protons, or mass number minus number of protons. Therefore number of protons equals to atomic mass minus number of neutrons. Again Z equals to number of protons. Therefore P equals to E. Therefore E equals to Z. This means in an atom number of protons equal to number of electrons. Therefore if atomic number equals to number of protons and number of protons equals to number of electrons, therefore we can also say number of electrons is also equal to atomic number. Okay, and if we substitute Z in place of P, we can also find atomic number. Okay, therefore Z equals to A minus N, and number of neutrons equals to atomic number minus number of neutrons equals to mass number minus atomic number. Okay, so these are the formulas that we can apply. চলো দেখি প্রতিটা ফর্মুলা স্যাটিসফাই করছে কিনা, আমার এই প্রতিটা ইকুয়েশনকে স্যাটিসফাই করছে কিনা। সোডিয়াম দিয়ে এক্সাম্পল দিয়ে দেখি। তাহলে সোডিয়াম কত ছিল? 2311। ওকে, তাহলে এখানে ক্যাপিটাল A is equal to 23, Z equals to 11, therefore Z equals to P equals to 11, P equals to E equals to 11. Okay, number of protons and number of electrons is 11. Let us calculate number of neutrons. N equals to A minus Z, তাহলে mass number minus atomic number, which is equal to how much? Which is equal to 12. Clear? মিললো প্রতিটা? দেখো প্রতিটা মিলবে, তুমি প্রতিটা মিলিয়ে দিতে পারবে এই ফর্মুলা দিয়ে। ঠিক আছে, তাই এই জিনিসটা আসে পরীক্ষায়, এটা দেয় টুকটাক, একটা অ্যাটম এক্স দিয়ে দিল, বললো যে ওর মাস নাম্বার এত, সব কিছু বের করে দেখো। ঠিক আছে, তো এটা ভালোভাবে ক্লিয়ার রেখো একদম মাথায়। ওকে, সো বেসড অন দ্য previous formulas that we found about atomic mass and mass number and atomic number, let us represent the first 20 elements of the periodic table. This is very important. Okay, this is very important for your exam purpose. এই first 20 elements periodic table এর থেকে কিছু না কিছু দেয়, তো আমরা সবকটাই একটা একটা করে দেখে নিই। ঠিক আছে, so the first element is hydrogen. হাইড্রোজেনের সিম্বল capital H. So what is the atomic number of hydrogen? Atomic number of hydrogen is 1. Mass number of hydrogen is also 1. So what is the number of protons? Number of protons is 1. Interestingly, hydrogen atom does not have any neutrons, and it has 1 electron. Okay, that is why its mass number is 1. Okay, because mass number equals to what? Mass number equals to number of protons plus number of neutrons. See, 1 plus 0 equals to 1. Clear? So in this way we can form all the 20 elements. Okay, so the next one is helium. Okay, helium, symbol of helium is He. it has an atomic number of 2 and a mass number of 4. So atomic number is the number of protons. Therefore, number of protons equals to 2. And what is the number of neutrons? Mass number minus proton. 4 minus 2, 2. And number of electrons is also 2. Clear? So let us move on to the next element. Next element is lithium. What is the symbol of lithium? Lithium is represented by Li. What is the atomic number of lithium? Atomic number of lithium is 3. দেখো atomic number একটা একটা করে বাড়ছে, হাইড্রোজেনের 1, হিলিয়ামের 2, লিথিয়ামের 3। তার মানে এখান থেকে একটা ইন্টারেস্টিং জিনিস আমরা বুঝতে পারলাম, পিরিয়ডিক টেবিলে যে অ্যারেঞ্জমেন্ট অফ atoms, that is based on what? That is based on the atomic number of all the atoms. Okay, so the periodic table arrangement is always based on what? It is based on the atomic number of the atoms. Clear? Okay, in case of lithium, the mass number is 7. Therefore, number of protons is 3. Number of electrons is also 3. What is the number of neutrons? Neutrons equals to A minus P. Okay, so mass number 7 minus 3, which is equal to 4. So let us move on to the next element. After lithium comes beryllium. 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 Beryllium is represented by Be. Okay, its atomic number is 3 এর পরে কি আসবে? 4. Okay, what is its mass number? Its mass number is 9. So number of protons is 4, number of electrons is 4, and what is the mass number? 9. Therefore number of neutrons is 9 minus 4. It has 5 neutrons. Clear? So the next element after beryllium is boron. Boron is represented by capital B. Atomic number of boron is 5. 4 এর পরে 5ই আসে, ঠিক আছে? Mass number of boron is 11. So number of protons is 5, number of electrons is 5, number of neutron is 11 minus 5, mass number minus atomic number, or mass number minus number of protons, that is 6. Clear? After boron comes carbon. Carbon is represented by capital C. Okay, its atomic number is 6 and its mass number is 12. So number of protons is 6, number of electron is 6, and this is 12 minus 6, 6. Clear? After carbon, the 7th element is nitrogen. In case of nitrogen, the representing symbol is capital N. What is the atomic number? 7. The mass number is 14. So number of protons 7, number of electrons 7, and number of neutrons is 14 minus 7, which is equals to 7. Clear? Okay, so after nitrogen, the 8th element is oxygen. Oxygen is represented by the symbol capital O. It has atomic number 8, it has mass number 16. So number of protons is 8, number of electrons is 8, and number of neutrons is 16 minus 8, which is also 8. After oxygen, the 9th element is fluorine. 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 Fluorine is represented by capital F. Its atomic number is 9 and its mass number is 19. Clear? So number of protons and number of electrons is 9. Number of neutrons is 19 minus 9, which is equal to 10. Is it clear? Then comes the first, not the first, actually the second. Look, helium is also a noble gas. Okay, why? I will state it as we move on in the chapter. First I will explain all the electronic configuration, what is stable electronic configuration, what is unstable electronic configuration, and then I will explain how we are determining which element is a metal, which element is a non-metal, which element is a metalloid, and which element is a noble gas. Okay, so this is neon. Neon is represented by the symbol Ne. It has an atomic number 10. 9 এর পর 10 হয়, তাহলে নিয়নের atomic number কত? 10. Its mass number is 20. Therefore number of protons 10, number of electrons 10, and number of neutrons is also 10. Clear? After neon comes sodium. I just explained the details of sodium, represented by Na. Its atomic number is 11, its mass number is 23. Therefore number of protons and number of electrons is 11, and number of neutrons is 23 minus 11, which is equal to 12. Is it clear? After sodium comes magnesium. Magnesium, it is represented by Mg. It is having an atomic number 12, it is having a mass number 24, Therefore its number of protons and electrons are 12 and number of neutrons is 24 minus 12, which is equal to 12. Okay, after magnesium comes the 13th element, aluminium. Aluminium is represented by Al. Okay, aluminium is represented by Al. What is its atomic number? After 12 comes 13, therefore atomic number is 13. Its mass number is 27, therefore number of protons and electrons is 13 and number of neutrons is 27 minus 13, which is 14. Okay, after aluminium, very important element comes silicon, SiLiCon. It is represented by Si, symbol capital S, small I. Okay, so atomic number is 14. What is the atomic mass or mass number? Mass number of silicon, remember, it is 28. So there are 14 protons, there are 14 electrons and there are 14 neutrons. Clear? After silicon comes phosphorus. Phosphorus. Okay, phosphorus is represented by the symbol capital P. It has an atomic number of 15. See, the arrangement is based on atomic number. The atomic number is increasing by 1 since the first element. বুঝেছো? এবার 1 থেকে 20 কেন বলি বুঝেছো? 1 থেকে 20 এলিমেন্টগুলোর অ্যাটমিক নাম্বারও 1 থেকে 20 হয়। পরপর একটা একটা করে অ্যাটমিক নাম্বার বাড়তে থাকে। আর মাস নাম্বারটা তো যে যার নিউট্রনের উপর নির্ভর করবে। তো এটার মাস নাম্বার কত? ফসফরাসের মাস নাম্বার is 31. Therefore number of protons and electrons is 15, but number of neutrons is 31 minus 15, which is equal to 16. Is it clear? Okay, so the next element after phosphorus is, just after phosphorus comes sulfur. Okay, sulfur is represented by capital S. It has an atomic number 16. Number of mass number is 32, so the number of protons and electrons is also 16. Number of neutron is 32 minus 16, which is equal to 16. After sulfur is chlorine. Chlorine is represented by capital C, small l. It has a mass number. It has an atomic number of 17. It has a mass number of about 35. Therefore number of protons and electrons is 17. Number of neutrons is 35 minus 17, which is equal to 17. Clear? After chlorine comes argon. Argon is represented by symbol Ar. It has an atomic number 18 and a mass number 40. Okay, so number of protons is 18, number of electrons is 18, and the number of neutrons are 40 minus 18, which is equal to 22. Okay, and now after argon comes potassium. Potassium is represented by K. It has atomic number 19, mass number 39. Therefore number of protons and electrons will be 19 and number of neutrons is 39 minus 19, which is equal to 20. Okay, and the last element that we need to study about is calcium, whose atomic number is 20, mass number is 40. So number of protons and neutrons are number of protons and electrons are 20. Number of neutrons is 40 minus 20, which is also equal to 20. So this entire chart is very important. You have to learn this entire chart. You only need to learn the atomic number and the mass number. The rest you can calculate using those formulas. Okay, this is very important. Okay, so how will we represent with symbols the first 20 elements? Okay, we just understood that what is the mass number, atomic number, protons, electrons and neutrons for the 20 elements. Now how will we represent them using symbols? Okay, so in case of hydrogen, hydrogen can be represented by, here we will place the mass number and here we will place the atomic number. Okay, so hydrogen will be represented by H11. Okay, how is helium represented? Helium is represented by He42. How is lithium represented? Li73. Beryllium is represented by Be94. Okay, after beryllium comes boron. Boron is represented by B115. Okay, after boron carbon. Carbon is represented by 12,6. After carbon comes nitrogen. Nitrogen is represented by 14,7. After nitrogen comes oxygen. How is oxygen represented? Oxygen is represented by 16,8. Mind it, I am writing all the mass numbers in the top region and all the atomic numbers in the bottom region. Okay, after oxygen comes fluorine. So fluorine is represented by 19,9. After fluorine comes neon. Neon is represented by 20 and 10. After neon comes sodium. Sodium is represented by 23,11. After sodium comes magnesium. How is magnesium represented? Magnesium is represented by 2412. Okay. After magnesium comes aluminium. Aluminium is represented by 2713. After aluminium comes silicon. Silicon is represented by 2814. Clear? After silicon comes phosphorus. Phosphorus is represented by P3115. After phosphorus comes sulfur. Sulfur is represented by 3216. Is it clear? After sulfur comes chlorine. Chlorine is represented by 3517. After chlorine comes argon. Argon is represented by Ar4018. After argon comes potassium. Potassium is represented by K3919, and calcium is represented by Ca4020. Is it clear? So this is how all the symbols are represented along with their mass number and atomic number. Symbols of the first 20 elements. Alright. Okay, so now the next topic is electrons, their arrangement and electronic configuration. This is a very important topic because if we can understand this topic clearly, we can easily represent electronic configuration of atom. We will understand electron transfer, we can understand ions, we can understand charge. Okay, we can completely understand how compounds are being formed, how molecules are being formed due to transfer of electrons, and how the electrons are actually arranged and why are they arranged in this manner. Okay, at first we will understand what exactly is electronic configuration. Okay, so what is electronic configuration? It is actually the arrangement of the electrons in different shells of an atom. Okay, so the arrangement of electrons in different shells of an atom, atom is known as electronic configuration. Let me give an example. Let us take the example of sodium. Okay, sodium has electronic configuration. It has electronic configuration 281. Okay, this means in its first shell, which is closest to the nucleus, that is K shell, there are 2 electrons. In the second shell, which is just away from the nucleus, that is L shell, there are 8 electrons. In the third shell, which is the farthest from the nucleus, that is the M shell, there are 1 electron. So how are the 11 electrons arranged in the sodium atom? They are arranged as first shell contains 2 electrons, L shell contains 8 electrons, and M shell contains 1 electron. So this manner of arrangement, that is how many electrons are arranged in the different shell of an atom, that gives us the electronic configuration of that particular atom. Clear? Okay, so before moving on to the arrangement, we need to know some of the properties of the shells or energy levels. Okay, so all the shells are also called energy levels because electrons possess a certain amount of energy while they revolve in a shell. Okay, that means electrons possess a certain amount of energy while revolving in a shell. Okay, and it has been found that the shell which is nearest to the nucleus has minimum energy. Okay, the shell nearest to the nucleus has minimum energy, and as the shells move away from the nucleus, the energy or their energy increases. Is it clear? Their energy increases. Clear? That means K shell has the lowest energy, L shell has more energy, M shell has more energy, N shell, and so on. Okay, that means K shell is closest to the nucleus. This is the shell which is closest to nucleus. So all electrons which are in the K shell are moving with minimum energy, okay? And as soon as we move away from the shell, as soon as we move away from the nucleus, energy increases, okay? Okay, so what is valence shell? Valence shell is the outermost shell of an atom. Outermost means the shell which is farthest from the nucleus, okay? The outermost shell of the atom is the valence shell, and it is farthest from the nucleus. It is farthest from the nucleus, okay? Is it clear? It is farthest from the nucleus. This means it has the highest energy. It has the highest energy. It has the highest energy, okay? So this can be easily referred to the fact that electrons are either taken in or added into the valence shell. মানে লস অফ ইলেকট্রনও কোথা থেকে হয়? লস অফ ইলেকট্রনও ভ্যালেন্স শেল থেকে হয়, অ্যাজ ওয়েল অ্যাজ গেইন অফ ইলেকট্রনও কোথা থেকে হয়? গেইন অফ ইলেকট্রনও কোথা থেকে হয়? ভ্যালেন্স শেল থেকেই হয়। এই দুটো জিনিসই কোথা থেকে হচ্ছে? ফ্রম দ্য ভ্যালেন্স শেল। তার কারণ কি দেখো, এটা নিউক্লিয়াসের থেকে সবচেয়ে দূরে, ইট ইজ ফার্দেস্ট অ্যাওয়ে ফ্রম দ্য নিউক্লিয়াস। তো নিউক্লিয়াস একে সবচেয়ে কম অ্যাট্রাক্ট করতে পারে। নিউক্লিয়াসের যে ইলেকট্রোস্ট্যাটিক ফোর্স অফ অ্যাট্রাকশন সেটা সে এই ভ্যালেন্স শেলের উপর কি হবে? সবচেয়ে কম। তাহলে তার জন্যই কি বলছে, এই শেলের এনার্জি সবচেয়ে বেশি। তা এখান থেকে ইজিলি ইলেকট্রন চলেও যেতে পারে, আবার এখানে ইজিলি ইলেকট্রন ফিরেও আসতে পারে। আমার কথাটা বোঝা গেল? এখানে ইলেকট্রন ইজিলি চলেও যেতে পারে, আবার এখান থেকে ইলেকট্রন ইজিলি ফিরেও আসতে পারে। বোঝা গেল? তার মানে যা লস অ্যান্ড গেইন অফ ইলেকট্রন হয় সবই কোথা থেকে হয়? এই ভ্যালেন্স শেল থেকেই হচ্ছে। তার কারণ কি, ভ্যালেন্স শেল আউটারমোস্ট শেল, এবং আউটারমোস্ট শেল বলে কি নিউক্লিয়াসের যে ফোর্স অফ অ্যাট্রাকশন বা ইলেকট্রোস্ট্যাটিক ফোর্স অফ অ্যাট্রাকশন সেটা সবচেয়ে কম এক্সপিরিয়েন্স করবে। যে যত দূরে চলে যাবে নিউক্লিয়াসের থেকে সে তত কম ফোর্স এক্সপিরিয়েন্স করবে, এবং তার জন্য এই শেলটা থেকেই যত লস অ্যান্ড গেইন অফ ইলেকট্রন হতে থাকে। ইজ ইট ক্লিয়ার? Okay, so while distributing the electrons in the various shells of an atom, there were a lot of problems. So these problems can be solved by following the rules of distribution of electrons. Okay, so who were the scientists to propose these rules? Niels Bohr and Charles Berry. Okay, Niels Bohr and Charles Berry proposed the rule of distribution of electron. ওদের এই যে দুটো রুল ছিল, এই রুলটাকেই আমরা কি বলি? এই রুলটা দিয়ে ইলেকট্রন ডিস্ট্রিবিউশন করা হবে, এই রুলটাকেই কি বলা হয়? বলা হয় বোর বেরি ডিস্ট্রিবিউশন scheme, Bohr-Berry distribution scheme, SCHEME, Bohr-Berry distribution scheme, clear? Of electronic configuration, clear? This was known as the Bohr-Berry distribution rule of electronic configuration, clear? So let us understand how the electrons are arranged in each shell. So let us move on to rule 1. Okay, rule 1. The first rule is maximum number of electrons in each shell of an atom. So what is the maximum number of electrons that can be placed in each shell is determined by the formula 2n square. It's determined by the formula 2n square, where n is equal to the number of shells as counted from নিউক্লিয়াস। তাহলে এইটা আগে বোঝাই ভালো করে, ঠিক আছে? নাম্বার অফ সেলস অ্যাজ কাউন্টেড ফ্রম নিউক্লিয়াস। 2n স্কোয়ারের রুলটা কি দেখো, একদম ভিতরে কি আছে? নিউক্লিয়াস আছে, তাই তো? এই নিউক্লিয়াস থেকে সবচেয়ে কাছে কে শেল, তারপরে এল, তারপরে এম, আগে কে, এল, এম, তারপরে এন, তারপরে ও চলতে থাকছে, ক্লিয়ার? তাহলে এন হচ্ছে এই শেলের নাম্বারটা, ঠিক আছে? প্রথম শেল কে, তাহলে কে এর জন্য এন কত? 1। তারপরে শেলটা নিউক্লিয়াসের কাছ থেকে, সেকেন্ড শেল এল, এটার জন্য n2, এটার জন্য n3, এটার জন্য n4 অ্যান্ড সো অন। বোঝা গেল? তাহলে n কি? n হচ্ছে নাম্বার অফ শেলস অ্যাজ কাউন্টেড ফ্রম দ্য নিউক্লিয়াস, ক্লিয়ার? তাহলে নিউক্লিয়াসের সবচেয়ে কাছে হচ্ছে কে শেল, তারপরে এল, তারপরে এম, তারপরে এন। ওকে, তাহলে নিয়ারেস্টটা নিউক্লিয়াসের থেকে 1 নম্বর, তাই কে শেলের n এর ভ্যালু কত? 1, এল শেলের n এর ভ্যালুটা কত? 2, এম শেলের n এর ভ্যালুটা কত? 3, এন শেলের n এর ভ্যালুটা কত? 4। তাহলে based on this n, let us calculate the maximum number of electrons that can be placed in each shell. Okay, so the first shell is K shell. So shell number is n, it is 1. তাহলে formula is 2n square. তাহলে 2 into 1 square, which is equal to 2. Therefore maximum number of electron in the first shell can be 2 ক্লিয়ার। তার জন্যই দেখবে সোডিয়ামে আমি কটা ইলেকট্রন বসিয়েছিলাম, ফার্স্ট শেলে 2টো ইলেকট্রন বসিয়েছিলাম। কেন? কারণ 2n স্কোয়ার রুল অনুযায়ী ম্যাক্সিমাম নাম্বার অফ ইলেকট্রন একটা শেলে সবসময় কত হতে পারে? 2টোই হতে পারবে, ঠিক আছে, নট মোর দ্যান 2, ক্লিয়ার। 2n স্কোয়ার রুল অনুযায়ী এল শেলে কটা হবে? এল শেলের শেল নাম্বার 2, তাহলে 2 ইন্টু 2 স্কোয়ার, দ্যাট মিনস 2 ইন্টু 4 8, তাহলে ম্যাক্সিমাম নাম্বার অফ ইলেকট্রনস ইজ 8। এম শেলে 3, তাহলে 2 ইন্টু 3 স্কোয়ার, দ্যাট মিনস 2 ইন্টু 9 18, তাহলে এখানে ম্যাক্সিমাম নাম্বার অফ ইলেকট্রনস ইজ 18। এন শেলে হচ্ছে 4, শেল নাম্বার ইজ 4, therefore formula is 2 into how much? 2 into 4 square, that means 2 into 16 is 32. So the maximum number of electrons that can be placed in the n shell is 32, and this so on. If there is O shell, P shell, then it will follow the same manner, where O will be shell number 5, P will be shell number 6, and formula will proceed in 2n square form. Okay. The rule 2 is electrons in the outermost shell. Always remember, rule 2 is very important for our arrangement. Okay, rule 1 থেকে তো আমি ম্যাক্সিমাম নাম্বার অফ ইলেকট্রনস একটা শেল যেটা অ্যাকোমোডেট করতে পারে সেইটা পাচ্ছি, কিন্তু একটা শেলে ম্যাক্সিমাম যতটা অ্যাকোমোডেট করতে পারবে ততগুলো ইলেকট্রনই কি ওই শেলের মধ্যে বসবে? সেটা কিন্তু হয় না। মাথায় রাখো এই কথাটা, যে although maximum number of electrons that can be accommodated is being calculated by the formula 2n square, but that does not mean that all the shell will be able to fill up that maximum number of electrons. Okay, how will the shell fill up electrons? It is based on rule 2. So what is rule 2? Rule 2 states that the outermost shell cannot have more than 8 electrons. Okay, this is very important. Outermost shell cannot have more than 8 electrons. The outermost shell cannot have more than 8 electrons. Is it clear? This means outermost shell cannot have more than 8 electrons. তার মানে কি, যেই না 8টা ইলেকট্রন বসে যাবে সঙ্গে সঙ্গে a new shell is formed. Okay, this is very important. So therefore a new shell is formed as soon as the outermost shell attains 8 electrons. ঠিক আছে, as soon as the outermost shell attains 8 electrons. This point is very important. Now let us understand this point. Okay, দেখো রুল টু ক্লিয়ারলি স্টেট করছি কি, the outermost shell, which is called valence shell of an atom, cannot accommodate more than 8 electrons even if it has the capacity to accommodate more electrons. তার মানে দেখো, এল শেলের 8টা ইলেকট্রন করার ক্ষমতা, এম শেলে ধরার ক্ষমতা কত? 18 খানা ইলেকট্রন, 18 খানা ধরতে পারে, কিন্তু যেই না এম শেলের মধ্যে 8টা ইলেকট্রন হয়ে যাবে সঙ্গে সঙ্গে নতুন শেল তৈরি হয়ে যাবে। ঠিক আছে, আমি পুরো একটা এক্সাম্পল করে এক্সপ্লেন করছি, আগে এটা বুঝে নাও। তাহলে দিস মিনস outermost shell of an atom can accommodate a maximum of 8 electrons except in the case of first shell, because first shell has the maximum capacity of only 2 electron. যার ক্যাপাসিটি 2, তার মধ্যে তুমি 8 খানা কি করে ঢোকাবে, তাই না? ওর ওই শেলটার ক্যাপাসিটি 2 খানা ইলেকট্রন ধরার, ও 2টোর বেশি ধরতেই পারবে না ইলেকট্রন, তাহলে ওর মধ্যে পসিবলই না 8 খানা ইলেকট্রন ঢোকানো। ক্লিয়ার? ওকে, সো লেট আস আন্ডারস্ট্যান্ড দিস কনফিগারেশন বেসড অন সাম এক্সাম্পলস. Okay, so I will be explaining rule 2 based on these 4 atoms: sodium, potassium, calcium and silicon. So at first let us consider sodium. What is the number of electrons in sodium? 11. Okay, so number of protons is 11 and number of neutrons is 12. So let us form the electronic configuration and atomic structure based on the rule 1 and rule 2 proposed by Bohr-Berry scheme of distribution. Okay, so n is equal to 12, p is equal to 11. First shell, that is k shell, k shell. Okay, k shell how many electrons can it accommodate? It can accommodate a maximum of 2 electrons. তো আমি k shell 2 electrons বসিয়ে দিলাম, তাহলে k shell 2টো ইলেকট্রন চলে এলো। তাহলে out of 11 minus 2, how many electrons are there now? There are 9 electrons. L shell has the maximum capacity of accommodating how many electrons? 8 electrons. So how will the 9 electrons distribute itself? In the L shell there will be 8 electrons. So 1 2 3 4 5 6 and 7 8. There will be 8 electrons in the L shell. Okay, so 9 minus 1 equals to 9 minus 8 equals to 1. So how many electrons remain? 1. So M shell will have 1 electron for sodium atom. Clear? This is the K shell, this is the L shell, this is the M shell. Therefore ইলেকট্রনিক কনফিগারেশন লেখার সময় এরকম ভাবে লিখবো না, ইলেকট্রনিক কনফিগারেশন কমা দিয়ে লিখবো। কি হলো তাহলে? প্রথমটায় দুটো, তারপরে শেলে 8টা, তারপরে শেলে 1টা। ওকে, সো দিস ইজ দ্য ইলেকট্রনিক কনফিগারেশন অফ সোডিয়াম atom. Mind it, this is sodium atom. Okay, this is sodium atom. Clear? Okay, so next let us consider potassium. Okay, so in potassium we have 19 electrons. Potassium atom, okay, potassium atom we have 19 electrons, 19 protons and 20 neutrons. তো চলো দেখা যাক তাহলে এখানে অ্যারেঞ্জমেন্ট কি হবে। আগে আমি নিউক্লিয়াসটাকে বানিয়ে নিচ্ছি। দিস ইজ নিউক্লিয়াস, protons equals to 19, neutrons equal to 20. Okay, okay, so the first shell has how many electrons? The first shell will have 2 electrons. Okay, because it has the maximum capacity, 2 electrons. K shell 2 electrons, তাহলে K shell এ 2 electrons বসিয়ে দিলাম। Out of the 19 electron, 2 electrons are in K shell. How many are remaining? 17. Now 17 electrons will have to be arranged. L shell has a maximum capacity of how many electrons? 8 electrons. So in the L shell there will be 8 electrons. So 17 minus 8 equals to, so will be 9 will be remaining. So let us place 8 electrons in K shell. 1 2 3 4 5 6 and 7 8. K shell, L shell. Okay, 8 electrons in the L shell. Now 9 electrons has to be arranged. Now what is the maximum capacity of M shell? M can accommodate 18 electrons, isn't it? একটু আগে টেবিলটা কি শিখেছিলাম? M shell এ 18 খানা ইলেকট্রন অ্যাকোমোডেট করতে পারে। তাহলে আমরা M shell ড্র করছি এবার। তাহলে উচিত কি ছিল? এই 9 খানা ইলেকট্রন যেটা পড়ে আছে, the remaining 9 electrons all should have been placed in the M shell, but now you will observe that is not the case, because based on rule 2, outermost shell cannot have more than 8 electrons. So at this moment M shell is the outermost shell, so I am placing electrons 1 2 3 4 5 6 7 8. Now as soon as 8 electrons are in M shell, a new shell will be formed. According to Bohr-Berry theory, as soon as 8 electrons are in the outermost shell, at a certain moment a new shell will be formed. Okay, so new shell is formed, that is N shell. M shell had 8 electrons, so 9 minus 8, number of electrons remaining is 1. So N shell will have 1 electron. Okay, so N shell will have 1 electron. I am placing in N shell. So the electronic configuration is 2 8 8 1. And electronic configuration, if it was written 2 8 9, it would have been wrong, because although it has capacity, M shell has, although it has got the capacity to accommodate 9 electrons, but as soon as 8 electrons are placed in M shell, a new shell will be formed, because according to Bohr-Berry rule, outermost shell cannot have more than 8 electrons. Okay, new shell is formed as soon as the outermost shell attains 8 electrons. তাহলে দেখো K shell এ ইলেকট্রন বসে গেল, L shell এ ইলেকট্রন বসে গেল। M shell এ যেই না 8টা ইলেকট্রন বসে যাবে, M shellটা তো আউটারমোস্ট, ওই মুহূর্তে কি M shell আউটারমোস্ট, তাহলে ওই মুহূর্তে M shell 8খানা ইলেকট্রন বসে যাবে, সঙ্গে সঙ্গে N shell তৈরি হয়ে যাবে, এবং N shell তৈরি হয়ে গিয়ে কি হবে? একটা ইলেকট্রন যেটা বাকি ছিল সেটা এইখানে বসে যাবে। তাহলে ইলেকট্রনিক কনফিগারেশন অফ পটাশিয়াম অ্যাটম কি হয়ে গেল? 2 8 8 1। 2 8 9 হলে ভুল। ক্লিয়ার? Okay, so after potassium let us consider electronic configuration of calcium. Okay, so let us see how electrons are arranged in a calcium atom. Okay, so in a calcium atom there are 20 electrons. Okay, so there are 20 electrons. So first is the K shell. K shell will have 2 electrons. Therefore 20 minus 2 equals to 18. 18 electrons remain. So we have to arrange it. So let us first draw the nucleus. N equals to 20. P equals to 20. The first shell is the K shell. Okay. In K shell there are 2 electrons. After that L shell. What is the maximum capacity? 8. So L shell will have 8 electrons. So in L shell there will be 8 electrons. So 18 minus 8, 10 electrons remain to be arranged. So first of all, let me arrange the electrons in the L shell. 1 2 3 4 5 6 7 8. Clear? There are 8 electrons in the L shell. Now then comes the M shell. Now what is the maximum capacity of electrons in M shell? M shell has maximum capacity of 18 electrons, of accommodating 18 electrons, but 1 2 3 4 5 6 7 8. As soon as there are 8 electrons, according to the second rule, a new shell will form. That means as soon as there are 8 electrons in the M shell, a new shell will form. So M shell will have only 8 electrons. And now how many are remaining? 2 are remaining. So there will be an N shell which will have 2 electrons. Clear? So the electronic configuration is 2 8 8 2. আর যদি ভুল লেখো তাহলে কি লিখবে? ভুলটা হচ্ছে 2 8 10. 10 হয় না, 10 হয় না। কেন হয় না? কারণ যেই না এম শেলে 8খানা ইলেকট্রন বসে এবং এম শেল আউটারমোস্ট শেল ক্যানট অ্যাকোমোডেট মোর দ্যান 8 ইলেকট্রনস, সঙ্গে সঙ্গে এন শেল তৈরি হয়ে যাচ্ছে এবং এন শেলে গিয়ে দেখা যাচ্ছে কতগুলো ইলেকট্রন হচ্ছে? 2খানা ইলেকট্রন। বোঝা গেল? ক্লিয়ার? ইজ দিস ক্লিয়ার? আর একটা অ্যাটম ছিল যেটা, সেটাও দেখিয়ে দিই, সিলিকন। ওকে, সো সিলিকন হ্যাজ হাউ মেনি ইলেকট্রন? Silicon has how many electrons? Silicon has got 14 electrons. Okay, silicon has got 14 electrons. It has 14 protons and it has 14 neutrons. Okay, so how are 14 electrons arranged? So let us start from the K shell. K shell will have 2 electrons. Okay, so first we form the nucleus. P equals to 14, N equals to 14. Okay, first shell is K shell. K shell will have 2 electrons. Okay, after that 14 minus 2, how many are there? 12. So L shell will have 8 electrons because it can accommodate a maximum of 8 electrons. 1 2 3 4 5 6 7 8. So L shell will have 8 electrons. And then remaining, how many are remaining? 12 minus 8 is 4. The remaining will be placed in M shell. Although it can accommodate 18 electrons, there are only 4 electrons remaining. So the 4 electrons will be placed in M shell. Okay, M shell will have 4 electrons. 1 2 3 4. So what is the electronic configuration of silicon? It is 2 8 4. Silicon atom will have electronic configuration of 2 8 4. Clear? Okay, so now that we know how to arrange the electrons, let us find the electronic configuration of the first 20 elements. Okay, so hydrogen has 1 electron, so it will have 1 electron in the K shell. Helium has 2 electrons, so it will have 2 electrons in the K shell. Lithium has 2 electrons, 3 electrons, so it will have 2 in the K shell and 1 electron in the L shell because K has a maximum capacity of 2 electrons. Beryllium has 4 electrons, so it will have 2 electrons in the K shell and 2 electrons in the L shell. Okay, 2 in the K shell and 2 electrons in the L shell. Boron will have 2 electrons in K shell, 3 electrons in the L shell. Carbon will have 2 in K and 4 in the L shell. Nitrogen will have 2 in the K shell and 5 electrons in the L shell. Oxygen will have 2 electrons in the K shell and 6 electrons in the L shell. Fluorine will have 2 electrons in the K shell and how many? 7 electrons in the L shell. Neon will have 2 electrons in the K shell and 8 electrons in the L shell. Sorry. Sodium will have 2 in the K shell, 8 in the L shell and 1 electron in the M shell. Magnesium will have 2, 8 and 2 electrons in the M shell. Aluminium will have 2 electrons in K, 8 electrons in L and 3 electrons in M shell. Silicon will have 2, 8 and 4 electrons in the M shell. Phosphorus will have 2, 8 and 5. Sulfur will have 2 electrons, 8 electrons and 6 electrons in the M shell. Chlorine will have 2 in the K shell, 8 in the L shell and 7 electrons in the M shell. Argon will have 2, 8, 8. Okay, it will have 8 electrons in the M shell and 8 electrons in the L shell. Potassium will have 2, 8, 8, 1 as we just understood previously, and calcium will have 2, 8, 8, 2. So in this way the electrons in the first 20 elements can be arranged according to Bohr-Berry rule of distribution of electrons. Okay, so the last topic that we will be dealing with in this video are isotopes. Okay, so in the first video I explained you Dalton's atomic theory, in which he said what? He said that in Dalton's theory it was clearly said that all atoms of the same element are exactly identical, but modern atomic theory proved it wrong because isotopes were discovered. Now what are isotopes? Isotopes are atoms of the same element. Okay, isotopes are atoms of the same element which are having same atomic number but different mass number. Is it clear? They are having same atomic number but different mass number. This means isotopes have same number of protons, but they have same number of protons but different number of neutrons. Okay, so that is why the mass number varies. Isn't it? That means they have same number of protons but different number of neutrons. They also have same number of electrons and the same electronic configuration. Okay, they also have same number of electrons and same electronic configuration. Why is it so? Now we already knew that an atom is electrically neutral and each atom has same number of protons and electrons. তাহলে একটা আইসোটোপে যা প্রোটনের সংখ্যা হবে আরেকটা আইসোটোপেও একই প্রোটনের সংখ্যা হবে, কারণ আইসোটোপস কি এমন কিছু অ্যাটমস যারা একই এলিমেন্টের অ্যাটম কিন্তু তাদের নিউট্রনের নাম্বারটা ডিফারেন্ট। দে হ্যাভ ডিফারেন্ট নাম্বার অফ নিউট্রনস, কিন্তু প্রোটনের সংখ্যা তাদের মধ্যে সেম। তাহলে প্রোটনের সংখ্যা সেম হলে কি হবে? ইলেকট্রনের সংখ্যাও সেম হবে, এবং ইলেকট্রনের সংখ্যা সেম হলে কি হবে? ইলেকট্রনিক কনফিগারেশন সেম হয়ে যাবে। সো ফ্রম দিস উই ক্যান সে আইসোটোপস হ্যাভ the same chemical properties. This is very important. Isotopes have the same chemical properties. Why? Because chemical properties depend on number of electrons. Okay, this is because chemical properties depend on the number of electrons. Okay, but how do they differ? Isotopes differ in physical properties because physical properties depend on the mass number. Isotopes differ in physical properties because physical properties depend on mass number, and mass number is different because neutrons vary in the isotopes. So isotopes have different mass number, hence they have different physical properties. Okay, is it very clear? They have different physical properties. Clear? Okay, so now let us take an example. Look, chlorine has two isotopes. See, one is Cl3517, another is Cl3717. That means this has the mass number 35 and this has the mass number 37. See, the mass number is different, number of protons is same, number of electrons is same, but number of neutrons in this case is 18 and number of neutrons in this case is 20. That means atoms of the same element which are having different mass number but same atomic number. Okay, so they will have the same chemical properties. Why? Chemical properties are dependent on electronic configuration. Isotopes have same chemical properties but isotopes will have different physical properties. Okay, because physical properties are dependent on atomic mass. Now let us consider some of the common examples of the isotopes. See, hydrogen has 3 isotopes, carbon has 3 isotopes, oxygen has isotopes, uranium and potassium. Okay, you have to learn these examples. In the next video we will understand chemical reactivity And why does atoms react, how are noble gases formed, what is stable electronic configuration, octet rule and duplet rule. Okay, so I end this video here.